good afternoon, everybody. Thanks for being here on a Sunday afternoon in a place that certainly has lots of other attractions to offer. I really appreciate you're here. And, it's great. I hope I will use your time well. This is a piece of joint work. I'm just sort of a speaker for that group of colleagues from Dalhousie University. So this is us. And I discovered, coming from Dalhousie, where I'm a relatively new addition, I've been there all of 9 months. It's often good to tell people where this place is exactly. So this is on the map of Canada. That's where we are in Halifax, Nova Scotia, just above the state of Maine. And some of the places there look like this, so I couldn't help but show you this nice picture. All right, so let's get underway here. What I'll be talking about is our work on trying to build a curriculum and, in fact, a program in data science at the undergraduate level. So this will be the main focus of my talk. In the latter part, I will also mention some of the work we're doing in building and proposing a graduate program with a slightly more sharper focus on text analytics in particular. And really, this is an invitation for discussion with colleagues that may be here and may be doing a similar thing. So this is what I'm doing. You know, I've been an educator for many years, and I come to think, and this has been very well expressed by Coetzee, the Nobel Prize for Literature 10 years ago, that we are very fortunate because, in a way, when we teach, it's us who learn most. And so he's put that very nicely by saying, he who comes to teach learns the keenest of lessons. And indeed, in going into this field, and I'm originally a machine learning data mining person, and trying to look at this whole analytics and big data, however you understand it, I think I've been fortunate to learn a lot. So, it's great to be able to do that and hopefully help people in working on these questions. So, you know, I will, of course, I think that's preaching to the converted. I won't argue long the importance of data science, big data. Then my main topic, how we do this program at Dal, the two initiatives, the undergraduate data science degree, which is a computer science specialization, and then the graduate program that we're also proposing as an addition. And of course, I'd like that to lead to a discussion about where the future is in all that. So, you know, you look around and an interesting, convincing number by McKinsey Consulting, which is an important group of people who I think to some extent form the agenda of many global players. So according to their study, there will be a shortage, just a shortage of about 150 or more thousand of deep analytical positions, whatever that means, but data analysts in the US alone in 5 years. So, you know, we usually, when we scale that to Canadian problems, it's 10 times less. So, okay, even 15,000 is a lot in terms of shortage. So, of course, educational institutions have an obligation to know about these things and look at them as opportunities. But, you know, not just the numbers in North America, but if you look, the World Economic Forum has put out a report in 2011, which says that this big data, however you understand it, creates unprecedented opportunities for development, for international development in particular. And that's very interesting because it's not just the, you know, the better life in the rich countries, but I think they see, and I fully agree, that if we do it right, it may help people in less fortunate places around the world. So an important field. And so what is it for us to make sure that the language I'm using, what's data science? Well, this is this idea of making big data accessible to decision makers. And that, of course, involves data analysis. And, of course, we're looking at that from the perspective of a computer science degree. That is a degree that will be part of the computer science curriculum with all the constraints and properties of this curriculum. And one of them is to work within the framework that can, for instance, be accredited by institutions such as ACM or KIPS in Canada. So, so how we sort of view that very briefly, so big part of this data science is extraction of insights or knowledge from data. And I think most people believe that it's a cyclical process, interactive. And so the analysts need to interact with the data. Somebody said nicely that they have to make the data talk to them. And I like that metaphor. So there has to be a focus on not just data mining and text mining, things that are bread and butter for me, but also looking at interaction and how to do that well, and visualization in particular. And if you want to do that in a cycle, then you need to make sure that you do all the computer part fast enough for the analyst to be a willing part of that loop. And that means that you have to look at HPC solutions to enable this. So this is sort of the high-level thinking that we did pondering that degree. We came into this idea of having the degree, incidentally, because we have an institute for big data analytics, which is more targeting research and graduate training. But by just opening it and having a presence, we have noticed that we receive a number of inquiries, international and national as well, about undergraduate training in this field. So that made us think that this is something to capitalize. And we have sort of gone out of our mandate a little bit and proposed to this data science degree, which is now fully approved, and we are starting admission for fall 2014. So I will very briefly tell you how the curriculum looks like. Sorry. We just sort of observed when we were doing that, that was April, May, working on the paper, that at that time there was no undergraduate specialization in data science in the calendars of Canadian universities. I have no doubt, and I have since learned that there are places working on that, and that's very good because we are not the wisest. Why should we have all the wisdom in the world? We'll be very happy to discuss that with others that do a similar thing, particularly, like I said, from the computer science point of view. So how does this undergraduate degree look in a nutshell? So first year, there's nothing special. In the second year, we require all the students to do probability and statistics and databases. These are, for most part, compulsory courses anyways. In the third year, we would give them a web intelligence class, a digital media class, and a computer graphics with visualization class. And in the fourth year, we have courses that are really more specialization. So for us, it's cloud computing, it's HPC, it's data science, which is a totally new course. I'll give you some of the contents, and some electives. So 2 out of 3 machine learning, particularly scalable, applied to large problems. Natural language processing with a focus on large text bases and web applications, and data mining and warehousing. So a mix of these courses the fourth year. So now a little bit about the courses in particular. What do we have in web intelligence? Very quickly, and this will be in the slides and the paper eventually, if it's published. So, nothing really revelatory here, although we would focus on, this may be modified, because we would really like to focus on methods that are scalable to large data sets. So, for instance, I'm not so sure support vector machines would make a cut in there. But, definitely some of the classical machine learning tools that are applied in this context. And some of the NLP, again, sort of more modern flavor, sentiment classification, visual text analytics, quite important. So that's for the web intelligence. For HPC, we would look at some issues in code optimization, multi-threading, programming, especially OpenMP parallelization techniques for loops, of course, and parallel programming in particular. So that's the HPC, again, I think fairly standard. Then we would have a course on cloud computing that will look at these techniques in particular. Deployment models, virtualization, of course, storage servers, resource replication, specialized cloud mechanisms, scaling, the existing services, particularly Amazon, and then, of course, Hadoop and MapReduce. So, the basic things you'd expect in this type of course. Now, the data science is a totally new course. In computer science, I don't think many curricula have that. So we will talk about fundamentals of data modeling, some discussion of data acquisition, particularly ethics, and that there's an important privacy component here that we will insist on. We will look at the whole process of doing data science, not just the analytical part, so how to structure a project, model selection, both analytical and predictive, model evaluation, implementation, communication with the model recipient, the actionable part, and then finally organizing and managing data science projects. And of course, there will be a larger project at the end of this class as well, with sort of hands-on and sort of displays the role of the capstone course, if you want, for this program. So this is the essential components of this undergraduate data science degree that, as I say, goes into operation fall 2014. And then we also have a proposal out for a graduate level degree, which is a little more specialized. We propose to look at text data, in particular, large text bases. Why? Well, 80%, according to many, of the data out there is actually text data. So while we are quite comfortable, we have good methods to process structured data, that comes in databases, it's in tables and all that. It's a different story for unstructured data, and we want to look at that. This would be a specialization at the graduate level that will attract students to big text research in general, and as a benefit, while they work on their master's or PhD degree, they will get a graduate certificate, or whatever name we think is better than that, maybe something a little more sexy, to give them this additional marketable skill. And this could be also taken as a standalone one-year degree. And this we are doing, in fact, in cooperation with two Canadian universities, Simon Fraser University. Fred was here earlier. Yes, he's right there. And the Université de Montréal, the natural language, applied computational linguistics group there. So this is something we have big plans for. A few interesting things about that sort of idea. There is 5 pillars. We have a curriculum, which I will talk about very briefly. But other things that are perhaps interesting, every student will have to do a project. And that project will be, for most part, done with a company. And it will sort of grow out of an internship. Because all the students in this program will do industrial internships. And I have to say that IBM and Steve in particular were really helpful in planning that component of it. But we also talk, of course, to SMEs as well, because we think that it's great to work with large companies, but some small companies also have interesting things to do. We insist on student mobility. So as you see, we have partners both nationally. So each student in this program will spend a semester either at Université de Montréal or at Simon Fraser. Their students will be coming to us. And we also have an international component. I don't have it on the slide, with a strong visualization group in Brazil at University of São Paulo. So these are sort of things that we want to emphasize, but also one of the things that we want to sort of embed in the entire curriculum is that our students will come out very conscientious about issues of data privacy. We will teach them data privacy preserving techniques. We will give them the idea about the legal framework of data privacy, and we would really train them in a way that they will go out in the world and implement this idea of privacy by design. And this is, the holy grail of privacy, as we all know, but nobody really knows how to do it exactly. And I'm not saying that we do know how to do it, but we have certain tools that help with that. So this is this TRIBE program that we have in mind, and that's hopefully coming in 2014, 2015. This is still more under works. The undergraduate part of it is already approved and will sail, as I said. So that's the graduate part. The courses in there that we will have for the curriculum part, data and text mining, so I will probably teach that. We have applied computational linguistics with a focus on bilingual data. This is something important in the Canadian context. What do I mean by that? Two things. First of all, we have a lot of bilingual corpora in Canada that are very interesting from the point of view of doing any kind of text mining. Particularly, we have the Canadian Parliament, the so-called Hansard corpus, more than 100 years of high-quality translation in both languages on any imaginable topic, as you can imagine. And so this is the parliamentary debate of the Canadian House of Parliament. Probably covers everything and more than you want. And also, bilingual sort of environment call for some techniques other than perhaps the standard one. So, most of the text mining work out in the world is done for English, but it's interesting to look at other languages as well. So we will emphasize this focus. We will have a course on visualization and human-computer interface. There is a high-performance computing in the cloud course. These are new courses. And an interesting thing at the end here is a professional practicum. So the idea is that if we prepare some of our students to go out and work with the industry, there is an array of soft skills that they may need that are normally not taught, at least to the best of my knowledge, in a graduate computer science environment. So we looked at that, and we have come up with a list of soft skills that would be good to teach, and we will call on particular groups that are present expertise in those within the university to help us and do that. So there are issues on data privacy and professional ethics that we will cover here. I've already mentioned that. I think many students in computer science, in my experience, really need some help with communications, particularly business presentations, proposal writing. It's good to give them an idea and train them in doing that. Project management, rudimentary elements of doing that, and also introduction to entrepreneurship, particularly intellectual property. How do you start a company, things like that. So this is a mixed bag, and I don't think that will be taught just by one person. Like I said, we will go and talk to people and groups that are out there in the university environment that will really help us to put that into, to make that course a reality. And I think the students will really benefit from that. And that's one difference between this and a sort of a standard graduate level curriculum. So we will also have, for particular tools, and whether it's Python or something else, for now we think about R, for instance, as something that's used out there in practice a lot for finding models in the data, large data. So we will simply teach that in a focused, say 1 week courses. And some of these courses, like I say, will be delivered in condensed formats. So tools that will inevitably change in time as we move on will be taught in that early on in the program. And this is a great opportunity in any graduate environment to involve postdoctoral fellows in training, which is something that they want to do and are very eager. And certainly they will do it in many cases better than your regular prof. So this is the outline of that graduate program. And this is sort of the basis of my message for my presentation today. Like I say, I'm sure many places worldwide are involved in similar initiatives. So I think it's a great opportunity for us to connect and started talking and exchanging ideas on how to do it better. I think time will tell. This is all very new and very exciting, and makes me makes me to go back to the very beginning of my academic career, where essentially computer science was in a similar position as this data science is now. There was a big debate, how to teach it, what's the program, what should there be, and what shouldn't, and how to structure it. And as we know, there is a general consensus globally as to what goes into a good computer science program. For this data science thing, we're not there yet, but I think we're at the beginning of this path, and computer science experience indicates that only by working together and talking about it, we'll get there in a shape and form that we want. So thank you very much.